Okay, like I told you guys on Monday, we have four main categories of quadrilaterals, okay, and we are learning about them one at a time. On Monday, we talked about parallelograms, which is actually a very broad category of quadrilaterals. Okay, we're going to break in this video and in the video on Monday, we're going to break parallelograms into three shapes. Okay, parallelograms encompass three different quadrilaterals. Okay, the first one, which we're going to talk about today, is the rectangle. Now, we are very familiar with rectangles. We've known what a rectangle was since like the first grade, right? Maybe even kindergarten. We know what a rectangle is, but sometimes we don't remember all the specific details, or maybe we've never learned all the specific details. Okay, the definition that they give at the top of the page here is that a rectangle is a parallelogram with four right angles. Now, they used the word parallelogram right there, didn't they? Okay, well, if you read this little paragraph right here, it says, because a rectangle is a special type of parallelogram, it has all the properties of a parallelogram. It has those five properties that we talked about on Monday that are true about parallelograms. Okay, but it's a special type of parallelogram. And what makes it special is that the diagonals of a rectangle have an additional special relationship, meaning there aren't just five properties of rectangles anymore. There's the five from parallelograms, but then they add two new properties to it to make it a rectangle. Okay, so it's a little bit more specific, a little bit more detailed. Okay, so that's what we're going to talk about today. All right, so in review, these first five up to this point right here, these first five properties are true for any parallelogram. Okay, opposite sides are parallel, so that means that side and this side, and this side. They're all parallel, right? The two opposite sides are parallel. The opposite sides are congruent. Okay, so this side is congruent to this side. This side is congruent to that side. Okay. Opposite angles are congruent. Okay, so this angle matches this angle, and this angle matches this angle. That's true for any parallelogram. Consecutive angles are supplementary. Okay, I don't have as much space as I had last time to write that, but you remember what that means. Okay, if I've got A, B, C, and D, okay, then angle A and B are supplementary. They add up together to make 180. B and C, C and D and A. Okay, all four of those pairs add up to 180. And the last thing we learned about parallelograms on Monday was that the diagonals bisect each other. So this intersection right here is exactly at the midpoint of both diagonals. Okay? Now, those were the things we know about all parallelograms. Well, a rectangle is a special parallelogram. Okay, it's a special type of parallelogram, and it has two more properties that regular parallelograms don't have. Okay, these two properties are that all four of these angles, instead of them just being congruent, okay, instead of the opposite angles just being congruent, all four of these angles for a rectangle, and we know this, have to be right angles. Okay, 90 degrees. So instead of just the opposite angles being congruent, all four of them are actually congruent. Isn't that right? Okay, and then the last thing that they say is that the diagonals themselves, okay, not just is this part congruent to this part and this part's congruent to this part, okay, that's not the only thing that's true. What the additional piece of information that's true based on number 7 is that diagonal DB is congruent to diagonal AC. Okay, so the two diagonals as wholes are congruent to each other. Okay, so that's the special things about rectangles that are not necessarily true about all parallelograms. So if we look at this first example, using these 7 attributes, these 7 properties or characteristics of rectangles, okay, using those 7 properties, we should be able to answer anything they throw at us about a rectangle. Okay, so let's look at example 1. Okay, they say quadrilateral MNOP is a rectangle. That means that all 7 things from the box above here are true. All 7 things are true. Okay, So then they go on and say, okay, MO, that is this diagonal right here, MO goes from here to here. They say that that's 2x minus 8. And they say that NP, that's the other diagonal, is 23. Well, what do we know about the two diagonals according to the properties of a rectangle? Well, this last one right here, number 7, says diagonals are congruent, which means I should be able to set these equal to each other. So 2x minus 8 equals the 23. Okay, 2x minus 8 equals 23. Okay, so now I start solving this. I add my 8, makes 2x equal 31. We divide by 2, and we're going to get a decimal, which is okay. Decimals are okay. We get 15.5. Okay, so the only thing we needed to know in order to set that equation up was that the diagonals are congruent to each other. They are equal. Okay, equal in measure. All right, so let's go to the next page. Okay, in example 2 here, they say quadrilateral JKLM, okay, that's the quadrilateral, is a rectangle. Cool, so they told us it is a rectangle. That means all 7 of those properties from the first page are true. Now they say LP, okay, that's from here to here. LP is 3x plus 7. And MK, that's the whole thing of the other diagonal, is 26. So, is LP congruent to MK? Not quite, right? LP is only half of the diagonal LJ, right? This little part right here is only half of this diagonal since the diagonals bisect each other. Okay, so LP is just half of the whole thing. So we have a choice. We can either double LP, because there'd be one of them here and one of them here, right, to make the whole diagonal. We could double it, or we could say that this half is equal to half of the other diagonal, since the diagonals as a whole are equal to each other. So it's up to you guys. It doesn't matter. Well, it's up to me since I'm making the video. I'm going to choose to double LP. Okay, so if I double this right here, I'm actually going to have 6x plus 14, right? So 6x plus 14, that's my LP, and I doubled it because I need 2 of those to make all of LJ. So LP doubled equals the whole other diagonal, which is 26. And now we solve. We subtract our 14. We have 6x equals 12. So obviously x equals 2. Okay? So do you see how that worked? They gave us, we still know that the diagonals as a whole are congruent to each other, but they didn't give us both the diagonals. They gave us half of one diagonal and then the whole of the other diagonal. So we had to recognize that they didn't give us all the information. Okay, let's look at example 3 now. In example 3, they tell us again that quadrilateral ABCD is a rectangle. That's good to know. All 7 properties from the first page are true for this shape. They tell us that AC, okay, that's this whole diagonal right here, is 4x minus 13, and that DP is x plus 7, DP. So this is exactly like example number 2, right? Exactly like number 2. So we can double the one that they only gave us half of, right? So we can double DP to get all of DB. Because if we know all of DB, that's equal to all of AC, right? Since the total diagonals, the diagonals are congruent to each other. So let's double DP. If I double that, that's going to be 2x plus 14, right? I doubled everything in it. And that equals 4x minus 13. Okay? So I start solving. Me personally, I would move my 2x since it's the smaller one. And I'm going to move my 13 since I moved my 2x. It kind of forces my hand a little bit. That goes away and that goes away. So now I've got 27 equals 2x. Well, we divide by 2 and our x will equal 13.5, right? So another decimal, which is still okay. We can get decimals. That's perfectly fine. Okay? They're kind of testing us to make sure that we're confident in our work here. Okay? All right. So that's how the diagonals relate to each other. Those three examples dealt solely with the diagonals. Now, let's take a minute to look at number 4. Okay? They give us two little bits of information. They have 10 angles labeled. 10 of them are labeled, and we've got to figure them out based on the little bit of information they gave us. Okay, they say that KLMN is a rectangle, right? Use the rectangle KLMN and the given information to find everything else. Okay, so what do we know if it's a rectangle? What do we know that angle L has to equal? Okay, angle L has to be 90 degrees, right? So does angle M, so does angle N, so does angle K, right? 4 right angles. All right, so if angle 1, just this little guy right here, is 70, what's left to make 90? Hopefully we can do that in our head, right? 70 and 20 make 90 degrees. Okay, so where do we go from there? Well, let's see. Using our knowledge of parallel lines cut by transversal, actually, let's wait a second. Let's go back to this for a second. Let's go back to the information they gave us here. They said angle 7 is 20 degrees. Okay, so angle 7 is 20 degrees. What does that make 8? Well, 7 and 8 together have to make 90 degrees. So if 7 is 20, 8 has to be 70. Now, what good does that do us? Well, if we know angle 1 and angle 8, then can't we figure out this angle right here? Well, yeah, because this shape right here is a triangle, right? This shape right here is a triangle. So if this is 70 and this is 70, that makes 140. How much more do I need to finish off the 180 for the triangle? Well, 180 minus the 140 would be 40, right? Now, that's not one of our angles, but it is helpful. Okay? Why is that helpful? Why would it be helpful to know that this angle right here is 40 degrees? Well, if we know that angle, then we can figure out angle 10. Okay? Because 10 and this 40-degree angle, right, these two right here next to each other have to make 180 degrees because they're a linear pair. Okay, so if this is 40, what is 10? Okay, hopefully you said 140, right? Because 40 and 140 make 180 degrees. Okay, so if 10 is 140, what is 9? Well, if 10 is 140, then its vertical angle, angle 9 right here, is also 140. Okay, so I'm just using prior knowledge, things we've learned before about vertical angles, about linear pairs, about triangles. Use all the prior information to figure this stuff out. Okay, now if I know that angle 7 is 20 and angle 9 is 140, can we figure out angle 6? Well, of course we can, right? Of course we can. 20 and 140 is 160. So angle 6 has to be the rest of that 180, which makes angle 6 20 degrees. Okay, so angle 6 is 20 degrees. And if angle 6 is 20 degrees, what is angle 5? It'd have to be 70 degrees, right? Because 6 and 5 together make the 90-degree angle of the rectangle. Okay? And then, so you kind of see how you can just follow it along, right? This is 40. What is this place that has a C on it? What is this guy right here then? Well, if that's 40, then its vertical angle right here is also 40. And if this is 40 and this is 70, how much left for angle 4? Another 70, which of course forces angle 3 to be 20 degrees. Okay, so all of these, like this problem right here, most of the information that we used didn't really have anything to do with rectangles. The only thing we needed to know about a rectangle that helped us with this is that all of its corners, all of its vertices form 90-degree angles. So angle L as a whole was 90, angle M was 90, angle N was 90, and so forth, right? That helped us figure out the little parts. And then we used our prior knowledge of triangles and parallel lines and vertical angles and linear pairs and all that stuff to figure out our missing pieces. Okay? All right, so let's go to the last page of these notes. Okay, I think there's only one example here. Yeah, let's just do this one example real quick. Okay? All right. It says quadrilateral RSTU is a rectangle. Okay, that's good to know. It is a rectangle. Okay? They tell us that angle RSU, that's this guy right here, right? RSU is 3x plus 5. And angle UST, that's, let's do this one in blue, I guess. There we go. Angle UST right here is 4x plus 4. Well, together, what do those two angles have to be? They make the whole corner at S, they make the whole angle S, so what do they have to add up to together? Well, together, the 4x plus 4 and the 3x minus 5 have to equal 90 degrees because it's a right angle, right? Our rectangles have right angles. So let's put our information together. We've got 4x, we've got 3x. That makes 7x. We've got a 4 and a negative 5. That makes a negative 1. And our 90 is just chilling over here. Then we add 1. Makes 7x equals 91. And last but not least, we divide by 7. And we get that x equals 13. Okay? Alright, like I said on Monday, these videos are available to you on YouTube. You can watch them as many times as you need to. I would use the rest of this class period. If you didn't finish the practice problems from yesterday, you should have finished. It should have been kind of easy to finish all that work in 45 minutes. But if for some reason you didn't, I would use the rest of this class period to finish that. If you have nothing else to work on, find something to keep yourself quiet. Okay? Do not give the subs a hard time. Okay? Treat them with respect, even better than you treat me. Find a way to keep yourself quietly entertained. Work on other classwork. Work for other classes. That's perfectly fine. Okay? But behave and keep yourself under control until the bell rings. All right. You will have a quiz on Friday. Okay. Tomorrow's Thursday. You'll practice these concepts about rectangles tomorrow. But then on Friday, you will take a quiz over parallelograms and rectangles. Okay. So study up, listen to these videos a couple times, watch them as many times as you need to, look over your practice problems, and study these notes for Friday. Okay. All right. Well, you guys have a good day.